In the last section in this chapter, we're talking about the dilution of acids and bases. This is something that chemists deal with all the time. And when I was actually teaching in a classroom was something I had to do quite often, because normally when you buy acids, especially acids, will come in great big huge jugs in a very concentrated form, and then you have to take it and you have to dilute that in order to make a solution that's not nearly so concentrated so that you can actually work with it. On occasion you work with a really concentrated acid, but they're very, very caustic. They can cause a lot of skin damage, they can cause lung damage if you inhale them, and so a lot of times, if possible, we try to dilute those chemicals as much as we can before we use them. So what I am going to show you as far as working these dilution problems is a little bit different from what he showed you. It's the same principle, but it will require less steps for you than what he showed you. And the way I'm going to show you how to do that is to use this equation, M1V1 equals M2V2. And what that stands for is first molarity times the initial volume equals the final molarity times the final volume. Now let's talk about what that means. Molarity, we already know, means number of moles that you have per liter of something, right? Just moles per liter. If I multiply that by a volume, and in this case I want to multiply by liters because I would want it to cancel out, what's that going to give me? Well, if liters cancels out, I'm going to be left with moles. And that's going to be the same on both sides of the equation. So my initial number of moles is going to equal my final number of moles. So again, if you think about that, if I have a container and I've got acid in it and it's got that many particles of, or that many molecules of the acid in it, if I just add more water to it, I haven't added any more particles of acid, I've just added more water to it. So the number of moles before is the same as the number of moles after when I dilute something. So that's why I can do this all in one step, because multiplying molarity times volume just gives me the number of moles. So let's do a couple of sample problems so you can see how this works. Sample problems for video number 7, there are 2. The first one says, how would you dilute 12 molar HCl to make 500 milliliters of a 3.5 molar solution? Okay, so first question is, what am I starting with? Well, I'm starting with 12 molar HCl. Okay? How much do I have to use to start with? Well, it doesn't tell me that, and in fact, that's why I'm doing this problem, because I'm trying to figure out how much I'm going to have to start with in order to do the dilution. What I know is that I need to end up with 3.5 molar HCl, and I need 500 milliliters of it, but remember, this has to be in liters, so I'm going to take that and convert it to liters, so 0.5 liters. So what I'm trying to find is the initial volume that I need of the 12 molar HCl. So in order to solve this problem, you're going to take 3.5 times 0.5, and then you're going to divide both sides by 12, and that will give you an initial volume of 0.15 liters. Now, you need to be careful on this kind of problem, because if I put this kind of problem on the test and I ask you, how would you dilute it? This is not the final answer. The final answer is you would dilute 150 milliliters of 12 molar HCl to a final volume of 500 milliliters. Okay? So this right here is the final answer. Just giving me a number doesn't tell me how to dilute it. This tells me how to dilute it, and that's what I will be asking you for if I ask you how to dilute something. So you're going to tell me how many milliliters of the molarity that you're starting with and what the final volume should be. okay? You're not going to tell me how many milliliters you're going to add. You're just going to tell me you dilute it until you get to 500 milliliters. So what you would have is you would have a container. You would measure out 0.15 liters, if that's where it was. You would have 0.15 liters in there, and then you would say, okay, well, here's my 0.5 liter mark, and you're going to add water up until you get to that point, okay? You don't measure the water and then dump them together. You put the acid in the bottom, and then you add water to it. So when we say dilute it, that's what we're talking about. Okay, so make sure that if you're asked a problem like that, and there will be some in your homework assignment as well, that this is not the answer, this is the answer, that you have to explain how you're going to dilute it, how much of the initial, and then to what final volume you're going to take that to. Okay, we're going to do one more example problem where actually we're going to be asked for something different, but we're going to use the same type of equation here. The second problem says, if you dilute 2.5 liters of a 5.6 molar NaOH solution to make a final volume of 10 liters, what will the concentration of the new solution be? So this time I'm not asking you how to dilute it, I'm just asking you what the final concentration is. So what am I starting with? Well, I'm starting with a molarity of 5.6, and I know that I've started with 2.5 liters. Okay, then I'm going to make a final volume of 10 liters, and I want to know what the resulting molarity is going to be. So that's how we're going to set the problem up. So you're going to take 5.6 times 2.5, divide that by 10, and then your final molarity should be 1.4. Okay? So on this type of problem, this is the final answer because I just asked you what the concentration was. Right? So as you finish up this chapter, you're going to be working with dilution, and then you'll be ready for your next test.